Hello students, in this video we will be learning about the basics of coordinate geometry. The word coordinate geometry, it tells you about the point or a location on a piece of graph paper. We draw a graph this way, okay, and we mark this as y-axis and this becomes our x-axis. The point where the y-axis and x-axis meet is referred to as the origin. Okay, now this graph paper that we usually have is referred to as, in geometrical terms, a Cartesian plane. So on this plane, if we need to locate a particular point in terms of x-axis and y-axis, okay, so we usually try to find out from y-axis, from 0 to y-axis how much it is, and from 0 to x-axis how much it is. We try to meet that point, something like this, and find out where is the location of that particular point. That is usually how we draw a graph paper for any linear equation. But what if there are 2 points? Maybe there is a point here that we have drawn, and maybe there is a point over here. Draw this, okay, and we need to find the distance between the points. How do we find out? Okay, every now and then we can't take a graph paper, so that is where coordinate geometry comes into picture. Okay, so the coordinates of a point means the location of a point, okay, in terms of x-axis and y-axis. See, how do we name a point? It is usually named as something like, say, 5, 6, say, where 5 tells you that this is on x-axis and 6 tells you it is on y-axis. So it is always x comma y. It is always given in this fashion, and that x comma y tells you the distance of the point on the x-axis here from the point 0, and the y tells you the distance of that particular point from 0 or the origin on the y-axis. Let us take an example. Okay, I'll do it this side, okay, or I'll take it this side itself. I'll just clear this part. Okay, let's say we have I'll just name this 0, then we have 1, 2, 3, 4, and over here we have 1, 2, 3 and 4. Let's say our point is somewhere over say here. How do we read this point? We read this based on where this is on our y-axis. That means when we are trying to read our y-axis, we look from 0 going upward, because this is our y-axis. So we see, okay, we see where this point meets this y-axis. I mean, on this y-axis, if we compare it, so it is like, okay, let's see if we draw a dotted line. Let's see how far it goes. So till 1, no. Till 2, no. Till 3, yes. So it is 3 on the y-axis. So I'm trying to just compare it with this. Then on the x-axis, okay, how do we find out how much it is on x-axis? See, x-axis is here, but our point is over here. So how do we actually find out how much it is? So let's say we do the same, we apply the same technique that we applied to find out y. We'll use the same technique to find out x-axis. So we take it till here. This matches with 1. We are running parallel to the x-axis now, and then we move further and we meet at 2. So that means the coordinate of this particular point that we drew is 2, 3. Why 2, 3 and not 3, 2? Because we always, as a protocol, write it x, y. X-axis point coming first, y-axis point coming next. Now, this particular point, okay, is known as an abscissa. Okay, what we call as x-axis is known as the abscissa, and this particular line, okay, is referred to as an ordinate. Certain terms that you need to know. Okay, so what is an ordinate? Proper definition: ordinate is actually a perpendicular line to the x-axis. This is the x-axis, correct? So it is the perpendicular line, but in reality what we actually call the ordinate? The y-axis. And what is abscissa? Abscissa is the line that is perpendicular to the y-axis. See, it is perpendicular, it's forming a right angle. And just like how the ordinate is forming right angle with x-axis, the abscissa forms a right angle with the y-axis. But the abscissa is actually what? The x-axis. Okay, so we usually know it as x-axis and y-axis. Okay, we rarely use abscissa and ordinates. Okay, but these are certain terms. So if it comes in the exam, something dealing with abscissa and ordinate, do not get confused or wonder where it is come from or what is it. Okay, abscissa refers to x-axis, ordinate refers to y-axis. So the term ordinate is also there in the chapter name, coordinate. See, ordinate. Yeah, so this is ordinate, y-axis. Now, when does the x-axis become 0? Think about it. When does the x-axis become equal to 0? See, the x-axis will become equal to 0. See, what we refer to as the x-axis? This, right? This line. Okay. When will it become 0? See, it went from 0 to 1 to 2, right? To meet over here, that's how we got 2. So from 0 it went. So when it will be 0? When the x-axis, when it is any point on the line y-axis. Okay, so x-axis becomes 0 on the y-axis. Similarly, y-axis turns 0 on x-axis. So over here, have a look. This was our line perpendicular to x-axis, which we called as y-axis, correct? Now it started from 0, then it went to 1, then it went to 2, then it went to 3. Finally we wrote 3 over here. Now it started from 0. That means the point on the x-axis is 0. That is when y-axis is equal to 0, correct? So any point on the x-axis, y-axis is 0, and any point on y-axis, the x-axis is 0. Just for your knowledge, this is when it becomes 0. When do both of them become 0? That is when do x-axis become equal to 0 and both y-axis become equal to 0? When they meet at the origin. So the coordinates of the origin are what? The coordinates of origin are 0, 0, showing that x-axis is also 0 and y-axis is also 0. So see, these are certain basics of actually a graph that you draw, but it is also part of coordinate geometry, where we don't draw a graph but we use certain formulas to find out the answer which we would otherwise find out using a graph paper. So remember, the abscissa of a point is its perpendicular distance from y-axis, and the ordinate of a point is its perpendicular distance from x-axis. Okay. Also remember that the abscissa of every point, that is the x-axis on every point on y-axis, is always 0, and the ordinate of every point on x-axis is 0. And remember, the coordinates of the origin, as I pointed out over here, are always 0. That means 0, 0. Okay, next video.